So here's our code from the previous video. I want to optimize this a little bit, and I hope that the way I was doing this was kind of eating you up and driving you nuts, and you just wanted to scream and shout at me and say, Jamie, do it this other way. But I didn't do it that way on purpose because I wanted to intentionally show you how they optimize. So I think we're done with that there on the right. I'm going to drag this out here so we can just focus on our code here. Are there any optimizations we could do in this code? Pause the video and think about it. If you noticed, I reused the 2 we had before when we were doing the 9 plus 2. So that's kind of a slick little optimization I did. But there's actually a much greater optimization I could do if you think about it. And the problem is, every time I'm trying to do an operation, or as I was trying to collapse our expression tree on the right, I kept putting the right values in a register before I did the operation. Okay, does that make sense? I'd say put 2, for example, move into EBX2, so I put this 2 in there, and then I'd say divide. Well, instead of putting it in a register, why don't I just say, hey, divide by 2? Does that make sense? And then I no longer need to move that 2 into a register. Okay, is that legit? Pause the video and think about it. Is that fine? Does that make sense? Okay, well, one way to find out, Control-Shift-B, build, and oh! That doesn't work. Why? I'll tell you why. It's because of the architecture of the CPU. We're dealing with the Win32x86 processor here, and the way that the instruction set's built and the way the processor's built is we cannot use divide with an immediate operand. Alright, so hopefully that makes sense. A little gotcha there. Well, that wasn't a very good optimization, was it? What's Jamie going to do now? I wonder. Well, we have this multiply here. I wonder if we could, maybe the same problem. Let's put the multiply here. Let's just put an immediate value here, and by immediate I mean it's immediately available with the instruction. Control-Shift-B, and same problem. Immediate operand not allowed. Let me get rid of this one. We're done with that one. So again, it's just the way the instructions are built. And if you look at instructions, they literally take up bits in the program file. Okay, but code takes RAM. All right, we've been sticking numbers into RAM and using them, consuming them, that kind of thing. But code literally takes RAM as well, and there's ways that we encode those bits into RAM, and it just so happens that the way we encode a multiply, we cannot have an immediate operand here. Again, why we call it immediate is when we encode the instruction, such as multiply here, we cannot embed the value 4 with that instruction. So that's something to keep in mind. So the multiply, I can't speed that up at all with the multiply. What was I doing anyway? I was moving the it was EBX, I think it was. Very good. Well, so we know multiply and divide are no good, but are there any operations here that we could optimize? All right, is there any? We can't do the multiply. We can't do the divide. Where's my divide? Did I lose it? I guess I got rid of it. Let me Control-Z back to the divide. Let me just make sure we're building. Okay, we can't optimize the multiply. We can't optimize the divide. So are there any operations we can optimize? Well, we got this +6, don't we? Didn't we move into EBX, the value 6, just to add that to EAX? Couldn't I just get rid of this and say, hey, add the 6? Do you think that will work? We can find out. Control-Shift-B. Hey, that succeeds. All right. So with add and subtract, the way these instructions are built with the CPU, we can embed the value directly in the instruction, with the instruction there. So now the add instruction in there, part of it says, hey, add EAX, and also embed the value 6. So now I don't need to do the temporary store 6 into EBX. I can just say, hey, add the EAX this value that I have immediately available to you. Hopefully that makes sense why I'm saying immediately. Okay, any other ones we can optimize? Let me bring the expression tree back up. We know we can optimize pluses, and we just did the 6. What about this 2 here? All right, you see this 2 here? Couldn't we just say add 2? Well, we could, but remember we stole it from a register here. Does that make sense? We already had the 2 in the register because of this 2 down here. And we know we couldn't embed this 2 in the instruction. So we can actually use the register down here since we already had it in 2. But so it's kind of 6s here. And I can't remember which one. If I wanted to, I could change this to a 2 and build that, and we'd get the same result. In fact, let me just prove that to you by running the debugger all the way to the end of our program. Right here, multiply, and we need the registers. Debug Windows registers. You see we got our 37 back in hex. So yeah, that's fine. And I can't remember, honestly, I can't remember which one's faster, and it probably doesn't matter at this level. But it's faster to either add an immediate value or to add a register to another register. So I can either add an immediate to a register, or I can add a register to a register, and I can't remember which one's faster. Probably doesn't matter. If I was going to guess, I would guess that the immediate value would be faster simply because it's there embedded directly in the instruction. Okay, so anyway, some optimizations we can do. Next video, we're going to do the scientific mode, which I encourage you to do before I do it, before you watch that video of me doing it. I encourage you to do the scientific mode. Remember, it's this expression tree we have here. Write it down on a piece of paper, collapse it as I'm doing. It'll be much more useful to you than just watching my video.